row. You want my arm?
Okay.
Yeah, earlier.
We're going to go ahead and get started. We only have 2 topics to cover today, so I'll probably get done a little early. Alright, the first thing we're going to talk about is probability and combinations. There won't be many of these on the SAT, but when they do show up, they're nice and easy ones to do if you know what you're doing. So, an example of a probability and combination problem is if you flip a coin twice, what's the probability of getting 2 heads? So the first thing you do is write out all of the combinations that you could get, all the possibilities. So if you're flipping a coin twice, you could get heads both times. You could get heads the first time, tails the second time. You could get tails both times, or you could get tails the first time and then heads the second time. So that's a total of 4 possibilities or 4 combinations, and only one of them is heads both times. So the probability of you getting that specific combination is 1 out of 4, or a fourth. So it's a probability combination problem. All right. Here's another example. Mr. Jones must choose 4 of the following 5 flavors of jelly bean: apple, berry, coconut, kumquat, and lemon. How many different combinations of flavors can Mr. Jones choose? So there's 5 flavors, but he's only going to pick 4 at a time. So you want to write out all the possibilities. Be careful to go in an order, like kind of have a pattern to it so that you don't leave anything out. So here's the 5 flavors. They each start with a different letter, so just put a letter for each flavor. And we're only doing 4 at a time. So we do the first 4 together, A, B, C, K. And then the other combination that would start with A, B, C would be A, B, C, L. So we list both the combinations that would start with A, B, C. And then we could have A, B, K. So we could have a combination that starts with A, B, K. That would be A, B, K, L. And that's the only combination that can start with A, B, K. Alright, because if you said A, B, K, C, well, we already have that combination. And then we've now exhausted all the combinations that start with AB, because we've done A, B, C, K, A, B, C, L, A, B, K, L. So now we're going to move to starting with AC, A, C, K, L. Now we've done all the combinations that start with A, so the only one left, B, C, K, L. So there's 5 possible combinations. Notice that the order doesn't matter, and being methodical is the key here, to have a method for how you're going to list all the possibilities. Alright, I know, we're already ready for the first quick quiz. Okay, so you're going to do quick quiz number 1. So you're going to flip in your, it's not number 1. Let's see which one it is. It is quick quiz 14. So if you flip in your pack, you're looking for one page that says quick quiz number 14. And there are 3 problems, the third one's just on the back. So take about 5 minutes to work those 3, and then we'll go over them. Okay, so we're going to go ahead and go over these. Alright, so on the first one, what's the probability of randomly choosing a white marble from a bag that contains 4 white marbles, 2 blue marbles, and 3 green marbles? So the probability, there's 4 white out of a total of 9. So 4 out of 9. So it's the desired outcome over all the possible outcomes. Alright, so it's the number that are white over the total number. Okay, the next one says if a diner at a certain restaurant may choose 1 item from column A and 1 item from column B, how many different combinations may the diner choose? So if you start making a list, you have steak and french fries, steak and spinach, steak and peas, steak and salad, steak and rice, right? You've got all these combinations that start with steak. 1, 2, 3, 4, 5 combinations that start with steak, because you can pair up steak with each of these 5. Then you could do the same thing for hamburgers. Hamburgers could be paired up with each of those. Alright, so for each of these things in column A, and there's 4 of them, there are 1, 2, 3, 4, 5 things that you can pair with them. So I'm going to make 4 lists that each have 5 things in them. That's a total of 20 combinations. Right. All right. The probability of randomly picking a chocolate cookie out of a certain bag is 1 out of 6, and the probability of picking a lemon cookie is 2 out of 9. If the bag contains only chocolate, vanilla, and lemon cookies, how many vanilla cookies could be in the bag? Okay, so the probability of picking a chocolate one is 1 out of 6. Lemon is 2 out of 9. So what's the probability of picking vanilla? Can you figure it out? If there's only chocolate, lemon, and vanilla in the bag, what do all of their probabilities have to total up to? Have to total up to 1, right? It's like percents. The probability of you pulling a cookie out is 100%, right? Every time you pull a cookie out, you're getting a cookie. The different probabilities are the different types of cookies. So with probabilities, the individual probabilities always have to add up to 1. So if I make this 3 out of 18 and this 4 out of 18, if I get a common denominator for these, then so far I have 7 out of 18. So how many are left for vanilla? 11 out of 18. So there could be 11 vanilla cookies. Right. But the key here is to remember that the probabilities of all these individual events have to add up to 1. So if I have 3/18, 4/18, that's 7/18, that leaves 11/18. Okay, so the other thing we're going to talk about today are sequences. Most sequence problems ask you to find a repeating pattern in a set of numbers. So when you have a sequence problem, you want to write out the pattern that's repeating until it starts repeating itself. And then extend the pattern out until you can answer the question. So for example, a rainbow bracelet has a repeating sequence of beads that repeat in the following order: red, orange, yellow, green, blue, violet. What's the color of the 602nd bead? You don't want to write it out to 602. The only reason they're asking this is because there's a pattern, and if you figure out the pattern, you can figure this out without having to write out 602 things in the sequence. So if you write out the pattern, we've got ROYGBV. ROYGBV. So that's 2 cycles through the pattern. Notice that the pattern repeats itself every 6 beads. So we go 6 beads and then the pattern starts over again. So 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. That means that every multiple of 6 is violet, right? This is the 6th bead, it's violet. The 12th bead is violet. The 18th bead will be violet. Every 6th bead will be the end of a pattern, end of a cycle in the pattern, and it'll be violet. So what multiple of 6 is closest to 602? Which one is going to be closest to 602 and be violet? Well, 600 is a multiple of 6. So the 600th bead would be violet. And after violet, we start over again. So the next one would be red. The next one would be orange. The 602nd bead would be orange. So a problem like this, they don't really expect you to go out 602 places. They expect you to recognize the pattern and figure out how to use the pattern to answer the question. Wow, that's fast. Okay. So, now we are on Quick Quiz 15. And there are only 2 problems on this one. So there's just an easy and a medium. So take about 5 minutes to do those 2, maybe a little less since there's only 2 problems. And then we'll go over them. And we're going to be done real early today. So. Okay. Go over these 2. Okay. A certain list contains 11 consecutive multiples of 3. the first number is 21. What's the middle number? This is kind of the same idea. You have a sequence of numbers. The first would be 21. And the sequence has 11 numbers in it. But I don't really need to go all the way out to the 11th number.
I did.
Right. Lots of people do that. But all I really care about is what's the middle. So in a group of 11, the middle number is the 6th number. So I really only need to go up to the 6th place. Right? So if I'm doing multiples of 3, I just add 3 each time until I get to what would be the middle, which is C. Okay. So you can save yourself a little bit of time by not going all the way to the 11th one. Alright, the first 3 numbers of a sequence are 1, 3, and 5 respectively. That means that they're in that order. From 1, it goes 1, 3, 5. Every number in the sequence beyond the first 3 numbers can be found by taking the 3 preceding numbers. So if I'm trying to find the next number, I'm going to take the 3 preceding numbers, subtract the second from the first, and add the third. So in this group of numbers, I'm going to subtract 3 from 1. That's going to give me -2. Plus 5 would give me 3. So you subtract 3 from 1 and add 5. So you're going to do 1 minus 3 plus 5. Right? That's what this says. This says that to find the next number in the sequence, you take the 3 preceding numbers, subtract the second from the first. So that means you're going to do 1 minus 3, and then add the third. And they want you to find the sum of the first 40 numbers. Well, we're not really going to find all 40 numbers. We're going to assume that at some point we're going to have a pattern. So now to find the next number in the pattern, we take the 3 preceding numbers. That would be 3, 5, and 3. And we do 3 minus 5 plus 3. And we get 1. And for the next number, we're going to take the 3 preceding numbers, 5 minus 3 plus 1 would be 3. Then for the next one, we're going to take the 3 preceding numbers, 3 minus 1, that's 2, plus 3 is 5. So now I'm starting to repeat my pattern here. It goes 1, 3, 5, 3, 1, 3, 5. The next one, if I do these 3 numbers, 1 minus 3 plus 5 is 3. So it's going to go 1, 3, 5, 3, 1, 3, 5, 3, right? Over and over and over again. So how many times will I have to do 1, 3, 5, 3 to get 40 numbers? I have to do it 10 times. And each group adds up to what? Each group of 1, 3, 5, 3 adds up to 12. So if I do 10 groups of 1, 3, 5, 3s to get 40 numbers, each of those 10 groups adds up to 12, then all 10 of them would add up to 140. I would consider that one hard, not medium, but
Oh, yeah.
it's all based on opinion there. So yes, that's the tricky part. Is a lot of people get the from. They think that second from the first means you do the second minus the first, but the from is actually switching the order. You're actually doing the first minus the second and adding the third. All right. I do plan